So I hope everyone is seeing my screen properly. Super. So again, welcome to my presentation. Today I'm going to talk about the Deepmime, which is the topic of my PhD research as well. It is the gesture similarity retrieval in large video collections. So I think most of you are the gesture experts and multimodal communication experts, so I don't need to talk a lot about that, and that's not my expertise. But all of us know that the multimodal communication has different modalities. It has a speech, language, and gesture, which translate in technical form in audio, text, and vision. Where the vision is the topic of my talk today. And that's the topic of my PhD thesis as well. And specifically, I'm talking about gestures, even though the gestures can have different forms, from the hand gestures, the body pose, and the gaze, and lots of other forms. I'm specifically talking about the hand gestures. It has a great deal of importance for linguistics in, for example, the co-speech gestures in human-computer interactions, and especially in robotic agents. For example, the robotic agents should understand the gestures to react accordingly. What is the current status of the gesture research from the computer vision point of view? There is a large video collection available, large-scale video collection available. We know about the Newscape dataset, which is a large recordings of the TV recordings, which basically relies on the annotations that we get for the gestures. These large-scale datasets needs human labor to annotate the gestures, and the methods that are already there from the computer vision point of view, that are for the gesture recognition and gesture retrieval, are a little bit limited because the amount of the data collections that are specifically used in the computer vision field to train the networks and produce this automatic search are limited regarding the amount of data, and also they are specifically sometimes relying on different sensors and different modalities such as depth, which are not always available when you're dealing with the everyday videos and the camera recordings. But the question is, could multimedia search engines help in this field to help the automatic annotations and reduce the human labor in the gesture annotations in the larger scale data sets? The multimedia search, you might have heard about the multimedia search engines. For example, our lab has a Retrieval system, which is a multimedia search system which takes the input as the text, as the sketch, and the image, and performs the search in the large video collections. And you can extract features from these queries, and you have the results. But the main limitation in such systems at the moment is that they are mostly based on the key frames, and they do not take the temporal dimensions into consideration, which is very important for modalities such as gestures, which the temporal dimension is very important. And adding such a modality to the search engines, for example, the query by gesture, where you can input your query by waving your hand, for example, and search for similar gestures within your video collection, could help in finding and it could help in the automatic annotations of these large video collections. Before I talk about the Deepmime, I would like to give a brief background on the computer vision aspects of the system, because I'm actually not sure if everyone has the background in this field. First, it is important to know how a computer sees the image and the video. From the computer point of view, an image is a matrix of 3 dimensions, which is the width and height and the channels of the image, and it sees the pixels, and the video is stacked frames of these matrices together. And the values of these pixels, the intensity of each pixel in the image. And to be able to process this data, to process these images and videos, there needs to be a visual descriptor to extract the features which are extracted from these pixels. And these features could be color features, could be histograms, could be sift features, and more recently there are deep features available out there. I'm talking about the deep features because they are being used in our work also, which are based on the neural networks, and the input image is given to the network, and from the lower level, the features that are being extracted are more toward the edges and the shapes, and the higher that it goes, like the deeper that the network gets, the features that are being extracted are more semantic and more higher level. We are all the time talking about the recognition and retrieval and the stage, but what is actual difference between these two, and why we are preferring the retrieval over the recognition in this work? Recognition is based on the limited number of classes, and you basically label your input based on those classes that you have. So the output of your system would be a class label given to that input. However, in the task of retrieval, you don't have the class labels anymore, and the output would be the list of the similar instances to your query image or the video. And that is specifically important when you have a very large collections, and your class labels or your annotations are not specific anymore. The task of retrieval is more preferred over the recognition. Going back again to what is the current status and how a retrieval system based on together with the query of the gestures could work. As I said, the automatic and semi-automatic annotations of the gestures could be possible with such a system. But again, there are multiple challenges in this field. For example, in the recorded scenes that are out there, there could be multiple people articulating the gestures in the scenes. There are gestures that continues over the camera shots, and they get cut because of this camera segmentation, the shot segmentations. And usually there is no additional sensor data or visual modalities such as depth to assist the retrieval and recognition systems and methods. And therefore, these are the challenges that we want to tackle in our system called Deepmime, which is basically a gesture retrieval system which is using the deep learning based methods to find similar gestures to the query in the multiple person, multi-angle scenarios, only based on RGB video feed. This work is over 3 years work of my PhD, and we have tried many different modules of the deep learnings and the feature extractions, which I will explain in the next coming slides, the different modules of our system. It contains 3 main modules. There is a pre-processing, feature extraction, and the retrieval. I will explain all of them in the coming slides. But the main important part of the system is to know what is the input and what we expect as the output of the system. The input is the RGB video. It could be recorded video. It could be camera feed that you record yourself and do something in front of the camera. And the output would be the top K videos containing the same gesture, the same visual, like the visual similar gesture. This K could be predetermined based on the use case and how many results you want to get from the system. And on the right, you can see the diagram of our system, which is the frames entering the multi-perspective spatial temporal person segmentation, and then the feature extraction and the retrieval. But talking about the individual modules of the system, First of all, it is the pre-processing that is very important. The pre-processing itself has different modules inside. First of them, which is very important and improves the performance of the system, is the segmentation. We use the segmentation to remove the background clutter. This is important in the gesture search, in the gesture retrieval, because in contrast to the activity recognition, for example, the background in activity, in any activity, could help the system to recognize what is being done in the frame. But in the gesture, any gesture could happen in any scenario. So the background could actually hurt the system to understand what gesture is being done. So it is beneficial for us to remove the background. On the other hand, on the other side of the pre-processing is the person re-identification method that we use to track people across the shots. This is something that I talked about in a previous slides, that it is important that for example, if you're considering the hands, if they get caught in the middle, then the gesture becomes discontinued, and you cannot understand what happens at some point in time to the future, and this would confuse the system that what the gesture and how the gesture ended. And for example, here you see an example of the output of the segmentation and re-identification system that we have, that the person got the ID of 3 and 2, and for example, the Ellen gesture continues over the shot, but the system could re-identify her over the next frame as well. The pre-processing part of the system, which is the spatial segmentation, is normally there is two kind of challenges in there. One of them is the occlusion. This occlusion could happen because of an object being in front of the person, because of another person being in front of one other person, or there is this text which is happening very often in the recordings of the newscape dataset that could basically occlude the gestures and the persons in the frame. And there is another challenge in this scenes, that there are usually multiple people in the scenes, and this could introduce another difficulty for the gesture recognition and gesture search retrieval system, because then you don't know which person to take into account when you want to extract the features of the gesture or to find the motions in there. So it is important to have a system to be able to segment and separate these multiple people and understand there is a person behind someone else or something else. And for this part, we use human key points extracted from the open pose, and the skeletal features are extracted from these key points, and there is the segmentation masks are created based on them, and these segmentation masks are used for the re-identification and for the feature extraction later. What I'm talking about, the mask, is this colorful mask that you see over the frames here, for example, or over the Ellen and the other guy. And this is the output of the segmentation method. We are using one of the off-the-shelf methods out there, which is called pose to seg, which is a very, very powerful method to extract such a masks, basically. And these masks are being used in the re-identification module. But this is important. This is actually a very important part of the system. The re-identification method is not only for the gestures that goes over the camera shot, but consider that two people are in a frame and doing some gestures. It is very important to know which person to consider when you are searching for that. For example, you have a query which is similar to one of the people's gestures in the frame, and you are interested in one of these persons. So we use this re-identification network to be able to create a sequence of individuals, frames of the individuals performing gestures in the videos. And these are used later for the feature extraction and later for the search. So basically we use this person re-identification module to track the people and create a database of them and create a smaller clips of each individual in the video and use them for the search later. For this, we use the pedestrian search network, which is a very typical task in computer vision to find the pedestrians, but with a slight the difference that the networks that are out there usually are taking the bounding boxes around people. So you have a bounding box around each people, and you take that box as the input to your search system. But in our method, we take the output of the segmentation as in here, just the masked version, and input it here for the search. So here it's another challenge coming, because the search usually happens when you have a data set or a collection of the things that you want to search in there. But when we have a video starting from the beginning, going over the video, you don't have that collection anymore. So you start with a person appearing, but you don't have any collection of or gallery of the images or instances of the people being there to compare this person that happened there. So here we basically create our gallery on the go by adding each person that we find on the video frames. So the first instance of any person that happens in the frame are automatically added to the gallery. And this gallery is being completed basically by basically comparing every new person that that appears on the scene, comparing that person with the gallery images that we have. And if the threshold, the similarity threshold between them is lower than certain amount of certain value, we add that new person to the gallery, because the similarity was not enough to say that this person is the same person as was in the frame before. So this gallery over time gets completed, and we update this gallery every 5 frames, because the person changes the pose and changes the way that it is recorded from the camera. So to make sure that over the course of the video, each person is recognized and being tracked properly, we update this gallery by the image of each person over after every 5 frames. And this is how it actually works in practice. So this is one of the scenes from the Ellen DeGeneres data set. And we have the Ellen and 3 guests coming in, and all of them are previously, there was a previous frame also that they added to the gallery, and to the next frame, all of these are being identified as the same person. And even after they change the pose and their faces being a little bit hidden, they are still being considered as the same person with the same ID. This is specifically happening because the features and the representation that is being considered from each individual is also based on, in addition to the pose, it's based on the clothing, it's based on the visual features. That's why, for example, their dress, their hair color, and the overall color of each individual also takes part in the recognition and re-identification of each person. So after the pre-processing, I mentioned that there is a feature extraction module. The feature extraction is the core component of every search system. Before I mention what feature extraction we use in the Deepmime, it is important to know what is the difference between different kind of features that are there. There is the spatial features, which are taking each frame into account at each time and extract a representation of that feature that is understandable for the machine at the end, which is a vector at the end. And all of these individual features that are extracted from each frame are aggregated at the end and create one feature vector to be used for the stage. However, the spatiotemporal features are taking multiple frames at each time into account, process them, and create one feature vector, one feature matrix for them, and then aggregate them over different stride of times and create one feature vector for these video clip at the time at the end. This is specifically very important for tasks such as activity recognition, activity search, and gesture search, because the temporal aspect of these tasks are very important, and it is very important to consider these temporal dependencies between each frame and not to disregard them based on just by an aggregation of the features at the end of the network. In our system, we use the LSTM network. So LSTM is a network that takes multiple frames of into account, and at the end, the feature vector that you have at the end contains all the information of the previous frames as well. In addition to the LSTM network for the feature extraction, we use the OpenPost for the skeletal information, and also the attention mechanism. The attention mechanism is a rather new concept in the computer vision, which basically is adding a weight to certain part of the image that we think that has more information to process. For example, in this picture, as you can see, the golf stick is given a bit more weight to the features, because it is important for the golf activity that the golf stick is there. In our use case, we give the attention to the body parts, specifically to the torso, to the hands, to the arms. And this attention helps the features to contain more information about these parts rather than the other parts of the body. Talking about the features now, it is important to know how these representations are learned to contain the information about the similarity as well. So we need to train, when we are talking about a network and the feature extraction, we need to be able to train this network. But how to train it to contain this similarity? There are many different ways to learn this similarity between the samples, and all of them are dependent on large amount of data and a huge amount of computational power. From these different methods that are there is one of them is the triplet network, which is taking 3 samples at a time and tries to extract this representation the way that the anchor sample has the maximum distance to a negative sample, which is not similar to the one that we are considering, and has the closest distance from the representation point of view to a similar sample. And this way the training goes on, and this way at the end, when you do the search, the distance, the Euclidean distance between 2 features of 2 videos which are similar has the less distance, and the other way for the dissimilar videos, this is not the case. And there is another way of training the network, which is based on the Siamese network, which takes a pair of video, and based on the label that if these 2 samples are similar or not similar, tries to maximize or minimize the distance between them. And this is all that is happening behind the scene. So that we train the model beforehand we process and extract the features of the data set and video collection that we have in the background. But what is happening in the inference stage and the execution stage is that you input a query, and this query is being processed, meaning that it goes through the pre-processing module. The mask is created, the background is removed, and the feature of that mask is extracted, and the feature is being compared to the features that are stored in the database. And this comparison is done by the Euclidean distance, and the closest examples and samples from the dataset are shown to the user. Here you see an example of the system. We have the top right view that we have is the query, and the 5 others are the results that are extracted from the system, from the query, from the collection. Here you see another example, which is again the top right one is the query, and the results are the other 5. This is a little bit different. This doesn't have the hand gestures necessarily, but it's more about the body pose, because not much of the hand gestures was happening in this frame. So I would like to show you some of the results that we got from our system. We performed an evaluation of the system based on a user study. The user study was the participants of this user study was novice participants which didn't have any knowledge on the field of linguistics. They were the computer science students of our university, and they were asked to rate the similarity of the gestures to the query. An example of this evaluation system you see on the right, which you have a query image and the result video is shown to them. And in many cases, it is important to see the PID of the person, because there are sometimes multiple people in the scene, and it is important to consider the same PID of which PID of the person you are talking about. We had 20 participants, 15 queries, and 5 results per queries were shown to each participant. This is 2 results that were that we got from the 2 of the results that we got from the evaluation. Nearly 70% of the results that we got said that the 5 results that were shown was similar to the query, and nearly 30% said that it is slightly dissimilar or dissimilar entirely. They were asked to rate the results based on the 4 ratings. Basically similar, slightly similar, slightly dissimilar, and dissimilar. And it was interesting to see the results on the right, that from the first query that was shown to each individual to the 15th one, in the first ones, everyone was rating everything more critically, and then over time this changed a little bit, and they were seeing the similar visual similarity between the gestures more often. And as we can see, the higher rating usually happened in the first and the second result that we got, and the third and fourth and 5 results were getting less rating based on the ratings of the participants. So what is basically happening next? We performed an evaluation of the system in our study, but the evaluation that we did was not considering the meaning of the gesture. It was solely based on the visual similarity between the gestures, which would be completely irrelevant to the meaning of the gestures that was there. So what is needed is actually a larger scale evaluation, which some people with the linguistic experts could participate and rate the system to see if the gestures that are extracted to be similar are actually similar based on the gesture meaning. Other than that, it is important also to integrate the system into the current video search engine. I talked about Retrieval earlier. It is a very powerful multimedia search engine, which could benefit hugely by adding the query by gesture and the gesture search, which this is something that is happening in the video collections in every movie, in every video so often that being able to use this as the query also can benefit such systems as well. Also, this is something that we've been working on in the previous Google Summer of Code with the Red Hen Lab. Also, we hope that we can incorporate such a pipeline, this Deepmime, into the existing pipeline of the Red Hen Lab to aid the linguistics in automatic and semi-automatic annotation, something like a rapid annotator or any other form that could help the linguist to get these annotations faster and being able to process them more quickly. So as the summary, our system is tackling the problem of the multi-person, multi-angle segmentations of problems, challenges in the gesture understanding and gesture recognition field. The pose information, we understood that is very important, and the attention mechanism improves the feature extraction hugely. And this might come a little bit weird because it's such an important topic, but Deepmime is the only gesture-specific retrieval system out there. There is not enough study on this topic, and it needs more attention. And there is a lot of open questions out there. There is a lot of research needs to still go there. And I'm a little bit ahead of time, but basically that's from my side, and I would like to thank you for your attention.